Hi guys, Ms. Rosacker here. We are diving into week 3 of learning, and this first learning is going to be about the imaginary units or the imaginary number. And I'm going to just walk you guys through these first set of notes, which are going to help you with learning what the imaginary unit I is and how we use it to solve problems. And then the second video I'm going to make is how you're going to solve quadratic equations using this imaginary unit. Okay, so here's your guys' first lesson. All right, so first we're gonna start trying to solve an equation that looks like x squared plus 9 equals 0. So we're gonna try to solve this guy. So the first thing you're gonna do when you're solving for x is you would subtract 9. So we get x squared equals negative 9. Then the next thing we would do is we would take the square root to get rid of this squared power right here. So I take the square root of both sides. Remember, when we do that, you have to put a plus or minus in front. So then on this left side, the squared and the square root cancel out. We're left with x equals plus or minus the square root of negative 9. Now, when you get to this point, up to all of your math experience up to this point, you were not able to solve these type of questions. You were stuck and you would say that this had no solution. So this really frustrated mathematician, and his name was Raphael Bombelli, and he decided that this is not a place that he wanted to stop solving math, and so he invented the imaginary number. And he said, okay, so since we get stuck right here, I'm going to make the imaginary unit I equal to the square root of negative 1 so that we're able to take this equation and simplify it out. So I can now break this into the square root of negative 1 times the square root of 9. And so he said, okay, well, now if I just say the square root of negative 1 is I can just solve this out. So I know the square root of 9 is 3, and the square root of negative 1 is I. So I can write this as plus or minus 3I. So it's treating numbers the same way as you would if you did the square root of 9, you get 3. But since we have this negative 1 inside of here as well, you know that you just throw an I on here to get that imaginary unit. So he just invented this imaginary unit. And these are really the two things you need to have memorized. So you need to know that the square root of negative 1 equals I, which this in this case is called the imaginary unit. And then if we just do a little bit of algebra with this, so let's say I is equal to the square root of negative 1. If I square both sides of that, my left side becomes I squared. And on my right side, the square root and the squared cancel out. So I'm left with just negative 1. So then you can also get the fact that I squared equals negative 1. So in just squaring both sides, I get that answer. So these are the two things that you need to have in order to work with imaginary numbers and imaginary units. Okay, so those two facts can help us simplify equations like the ones below. So we're going to simplify these guys. So if I have the square root of negative 4, I'm allowed to break this into the square root of negative 1 times 4 because negative 1 times 4 is still negative 4. And then I know, based on the imaginary unit up here, that the square root of negative 1 is I. So I'm going to replace the square root of negative 1 with I. And I know that the square root of 4 is 2. So this just equals 2I. Now in this case, this doesn't have a plus or minus inside or outside of this because it already had the square root in this problem. We didn't write it in. Okay, so same thing here. I can write this as the square root of negative 1 times 25. The square root of negative 1 is I, and the square root of 25 is 5. So this is just 5I. Okay, now these are just a little bit different. Think about these like x's. So if I did 2I times 3I, I'm allowed to do the 2 times the 3, so this becomes 6. And then I can do the I times the I, and that becomes I squared. Now I can simplify this a little bit further because using the fact up here that I squared equals negative 1, anywhere I see this I squared, I'm going to replace it with the negative 1. So I'm going to plug in negative 1 there. So that means this answer now officially simplifies down to negative 6. Okay, same thing here. Now we have to be really careful with this 2I squared. So that means that there's really 2 of these. So you can write it out like this if this helps. You have 2I times 2I because there are 2 of those based on that exponent times negative 5I. So now we're just going to multiply. So I'm going to do 2I times 2I first. So if I do 2 times 2, that becomes 4. And then I times I becomes I squared. Now remember, anytime you see this I squared, you're going to replace it with a negative 1. So this becomes 4 times negative 1, which is just negative 4. And then don't forget, we also have this negative 5I to multiply by. So I'm going to write times negative 5I here. So then if I do negative 5 times negative 4, this becomes 20. And then I. So this simplifies down to be 20I. So that's how you guys use it. Again, these are the only two things you need to remember. If you see a square root of negative 1, it's I. If you see an I squared, it's negative 1, and vice versa. Okay, the last part of this video is simplifying patterns of I. So if we have even degrees, the steps are, we're just going to write them down first, are we break them into I squared raised to some exponent. So we break them into I squareds and then simplify. So let's do some examples. Okay, so first example we're going to do of an even degree. So let's say I have like I to the fourth, and I want to figure out what that simplifies down to be. So what I'm going to do is I'm going to break them into I squared. So the easiest way to do this is to take this exponent and divide by 2. Remember, this is only if it's even. So if I do 4 divided by 2, that means there's going to be 2I squared. So I'm going to write this as I squared squared. So that means if I multiply these two 2's together, I get back to this 4. So this 4 divided by 2 ends up being my exponent. And then what we do is we replace this I squared with -1 because we know that's what it equals. So then I can write this as -1 squared. And then if I do -1 squared, -1 times -1 becomes a +1, and then that's my final answer. So I to the 4th power equals 1. Okay, let's do another one. So if we have I to the 10th, we think about how many I squareds we can break that into. So easiest way to do that is divide this by 2. We get that to equal 5. So that means my exponent should be 5. So we do I squared to the 5th. So whatever dividing by 2 here, this becomes a 5, that becomes my exponent. And then multiply these to make sure that it works. So 2 times 5 becomes 10, so I know that I'm good. Then I replace that I squared with a -1, and it's raised to the 5th power. So now let's think about this. If I take -1 and I multiply it 5 times, that's what it's telling us. Are we going to end up with a +1 or a -1? Excuse me. So it's really doing this. So if I do -1 times -1 right here, that becomes positive. And then +1 times -1, this now becomes -1. So then if I do -1 times -1, that becomes +1. And then +1 times 1, this simplifies down to be a negative. So this is -1 is going to be your final answer. So think about it in this way. If you take a negative number and raise it to an even power, it's always going to come out being positive. If you take a negative number and raise it to an odd power, it's going to come out being negative. So this final answer is going to be -1. Okay, let's do one more of an even degree. So let's do I to the 22nd. So I'm trying to figure out how many I squareds I can break that into. So if I do 22 divided by 2, that becomes 11. So my exponent right here has to be 11. And then just double check, 2 times 11 becomes 23 or 22. And then I replace I squared with -1, raise it to an 11 power. This is an odd degree. So if I multiply a negative number by an odd degree times, this is going to come out to be -1. So anytime that you have these even degrees, you're going to break them into I squareds, put whatever exponent is here. If this exponent is even, it equals 1. And if that exponent is odd, it's going to equal -1. So your only 2 answers that you can get for even degrees are going to be 1 and -1. If you don't get one of those final answers, then you know you did something wrong. Okay, then we're going to get into odd degrees because it's possible for the imaginary unit to be raised to a higher degree that is an odd. So let's do like I to the 5th. So what you do, or write the steps first, is you peel off one I first, and then treat problem like an even degree above. Okay, so that's our step. So you have I to the 5th. The first step is to peel an I off of here. So if I take an I off of here, I'm going to write it like, there's the I took off. If I take an I out of here, I have 4 I's left, so I to the 4th. If I add these together, I still have the 5, so I just took an I off of here. And now what I'm going to do is I'm going to take this I to the 4th, and I'm going to treat it just like we did above. So I'm going to break it into I squareds. I know there's 2 I squareds in I to the 4th, because 2 times 2 becomes 4. And then I replace the I squared with the -1. And then I take -1 and square it. So this is an even number. This is going to come out to be a +1. And then don't forget about this I. So all along we had this extra I in front. So now if I do I times 1, this simplifies to be a positive I. Okay, let's do it again. I to the 13th. You first peel off an I. So if I take one I out of here, I'm left with 12 of them. And then I want to think about how many I squareds are in here. So what's the number I can multiply 2 by to get 12? Well, it's 6. So I'm going to write this as I squared raised to the 6 because 2 times 6 becomes 12. And I have this other I in front. And then we're just ignoring this for now. Okay, then I'm going to replace this I squared with -1 raised to the 6th power. This is an even degree. So if I take a negative number raised to an even degree, it's going to come out to be positive. So that's +1 times I. This ends up being a positive I again. Okay, last one, I to the 27th. So first up, it is odd, not even. So you have to peel off an I. And then I have 26 left over. So peel off an I times I to the 26th. How many times or how many I squareds fit inside of here? So if I take 26 and I divide by 2, I end up getting 13. So I squared to the 13. And then I have this original I out here. Okay, then we're going to replace that I squared in the middle with a -1. Everything else stays the same. So now if I do -1 raised to an odd number, this is going to stay negative. So this is -1 times I. And if I do -1 times I, this is going to come out to be a -I. Okay, so odd degrees, we got 2 answers. This should be an I or a -I. And if you don't get those as answers, whenever you start with an odd degree, then you know you did something wrong. So what you're going to do is you're going to take this step by step, follow the directions, and you should end up with one of the final answers of 1, -1, I, or -I. Those are the only 4 final answers you should have whenever you're simplifying this down. Okay, so your guys' homework is going to be to just practice some of this, make sure that you guys understand how to take this imaginary unit and play around with it and get final answers. As always, if you are stuck on anything or confused on how to do these problems, please let me know. There is going to be a second video here in a second of how we're going to use these imaginary units to actually solve our equations. And yeah, that's it. Hope you guys are having a great day.